Okay, this is our last topic for the entire course. So our last topic for this chapter, this unit, and the entire Math 30 course. So what we're going to do is we're going to look at an application of the C. So we talked about yesterday, if I gave you 4C2, that means we're choosing 2 out of 4 objects where order doesn't matter. This C notation has a few applications, and the one that we're going to look at is the binomial theorem. And we're going to use this formula a little bit, which looks confusing, but once I explain it to you, you'll see it's actually not too bad. Where this comes from is Pascal's triangle. So in the old days, there was a mathematician, Louis Pascal, and he came up with this number pattern, and it's a pretty easy pattern. We just start at 1, and then on our next row, we basically add the 2 numbers above it. So we'd add the 0, there's nothing there, plus the 1, which would give us 1, and then we'd keep doing that all the way down. So the 1 and 1 would give us 2, 1 and 2 gives us 3, 3 and 3 gives you 6, and so on. So you get 1s going down the sides, and then the middle numbers add up. So we could do another row if we wanted to. We could continue this triangle as many times as we want. So we'd have 1, 5, 10, 10, 5, 1 would be the next row. We could do another row. It would be 1, 6, 15, 20, 15, 6, and 1, and so on. So Pascal's triangle, what's weird about it is it fits a lot of things. We get questions like doing NCR stuff, which I'll show you in a second. It works for pathways. So what I mean by that is if I gave you one of those questions where we were going from corner to corner, if I said how many paths to go from A to B, you could actually solve this using Pascal's triangle. All we do is we start with 1. I kind of picture the triangle being sideways. So you'd have 1 at all the sides like that, and then we just add them up. So 1 plus 1 would give you 2. Here we got 1 plus 2 would give us 3. 2 plus 1 would give us 3. 3 plus 3 gives us 6. 3 and 1 gives you 4. 6 and 4 gives us 10. So we'd see from A to B there would actually be 10 different paths to take. And the way we did this the other day, we'd say we have 3 and 2, so we'd say there's 5 factorial over 3 and 2 factorial. And if we actually do that, that'd be 5 times 4. 3, 2, 1 would cancel, divided by 2, which gives us 20 divided by 2, which is 10. So we do get the exact same answer no matter what. We don't do these pathway questions as much anymore, but it would still work. What we are going to do is look at it in terms of using the NCR notation and then apply that to binomial expansion. So if we take the C notation and we start at 0, so we say our first row is 0 and our first column is 0, we can actually repeat the pattern. So we go 0, C0, 1, C0, 1, C1, 2, C0, 2, C1, and so on. And if we actually solve for each of these, 0, C0 is 1, 1, C0 is 1, anything C0 is 1. And all of these ones, 1, C1 is 1, 2, C2 is 1, so those are also 1s. Anything that's C1 is the same number, so we'd have 2, 3, 4. We also know that the opposites occur, so you'd have 4 and 3 and 4C2. If you type that in on your calculator, that gives you 6. So if we compare those numbers in the table to our Pascal's triangle, it's identical numbers. So that means our next row of Pascal's triangle was 1, 5, 10, 10, 5, and 1. So that means those have to be the same thing as 5C0, which it is, 5C1, which it is, 5C2 is equal to 10, 5C3 has to be the same, so that's equal to 10, 5C4, that has to be the same as 5C1, which is 5, and then 5C5 is also 1. So we do get the same number pattern if we use the C notation. The only real trick is you got to remember you're starting at zeros all the time, so we get sort of an extra spot. So now what we want to do is compare this to binomial expansion. So if you take anything to the 0, it's always equal to 1. So that one we don't need to worry about. But if I give you x plus y to the 1, that equals x plus y. But I'm going to put in 1s and exponents of 1s just to see it. If we have x plus y squared, remember that would be x plus y times x plus y. If we FOIL that out, we would get x squared plus xy plus another xy, which we can combine to give us 2xy, and then y squared. If we did x plus y cubed, that means we just take that answer that we just had and multiply it by another x plus y. So if we FOIL this one out, we're going to get 1x cubed, then 3x squared y, 3xy squared, and 1y cubed. And we can keep doing this over and over again. And you can see now that the front numbers also follow our Pascal's triangle numbers. The only thing that's different is our x's and y's. You can see the pattern sort of changes. So let's do the next row. So if I gave you x plus y to the 5, we know from Pascal's triangle it should be 1, 5, 10, 10, 5, 1. So that means we should get 1x to the 5th, because that exponent has to match. Then we'd have 5, but it'll be x to the 4th, y to the 1. Then we'd have 10, x to the 3, y to the 2. So our x's go down and our y's go up. Then we'd have 10, x to the 2, y to the 3. Then we'd have 5, x to the 1, y to the 4. And then our last one would be back to 1, y to the 5. So you can see to actually FOIL these out, it's a lot faster just to follow the pattern and use Pascal's triangle to help us figure out that pattern. So the front numbers, we're gonna instead of using Pascal's triangle, we're gonna use the NCRs. So it'd be in this row we'd have 5C0, and then 5C1, 5C2, and so on. And then you can see the x's, the first one gets smaller and smaller and smaller, and for the y's, it gets bigger and bigger. So what that means is we can actually solve for a lot of these. I'm going to come back to this formula in a second. So let's look at the exact same question, but a different formula. So x plus y to the 7. So using our pattern, we know it should be 7c0, and then we'd have x to the 7th and y to the 0. That'd be our first term. Then we'd have 7c1, x to the 6th, y to the 1, and we just keep on going. 7c2, x to the 5, y to the 2, 7c3, x to the 4th, y to the 3, and I'll start a new row, 7c4, x to the 3, y to the 4, 7c5, x to the 2, y to the 5, 7c6, x to the 1, y to the 6, and our last one would be 7c7, x to the 0, y to the 7. So the pattern's pretty easy, and most people can get that pretty good. The only thing you want to do now is simplify these. So 7c0 is just 1, and we have x to the 7, and y to the 0, which is also 1. So we just write it as x to the 7. The next one would be 7c1, which is 7, x to the 6y. 7c2 is 21, so we'd have 21 x to the 5y squared. 7c3 is 35, so we'd have 35 x to the 4th y cubed. 7c4 is going to match, so we'd have 35, or I'll do it as a new row again, 35 x to the 3 y to the 4. And then 7c5 will be the same as the 2, so we're back to 21 x squared y to the 5th. 7xy6, and our last one would be back to 1, just y to the 7th. The x's go away. So it's a pretty easy pattern to figure out, but it's kind of a pain because you got to rewrite them all out. So if you get numbers like 8, 9, 10, it's just going to take longer and longer. So quite often what we're going to do is we're just going to look for one particular term. So one thing that's interesting to note is we got 7 as our exponent, but we actually get 8 terms because we're starting with that 0. We actually get one more term than what's listed there. So if I said find the 4th term in this list, what we'd be looking for is the 4th one from the beginning, which would actually be 7c3. So if I said find the 4th term, we could actually go right to that without listing them all out. Because if we know it's the 4th term, we'd actually have a number of 3, so 7c3. And then we know that if it's a 3, it's got to be y to the 3. That means we'd have to have our x to the 4th would be the other one. So that's where this formula comes into play. So it looks confusing, but what it's basically saying is to find any term. So if we look at the one that we just had, so I had x plus y to the 7, and I said find the 4th term, or term 4. So what we had to do is we had to have we used a 3, right? Remember it was 7c3. So what we want to do is we want to say, okay, well if that number is a 7, we want term 4, we actually got to go 7c3, and then we'd have x to the 4, we'd subtract those two, and then y to the 3. That was our answer. So to make a formula out of this, we actually have to do one less number. So we write our term as k plus 1. So if we want term 4, we actually have a k of 3. And then 7c3 is that part. Our n minus k is 7 minus 3 would give us 4. And then our k is 3. So all you have to do when you're doing these questions is when you see the number, so in this case x plus y to the 7, we want to think of our n as being the number of terms. So if we want the fourth term, we actually want 3. You want to do one less. Sorry, we want our n to be the total, so that's our 7, and our k is the one less. And then we just plug it into the formula and it works out pretty good. So let's try a different one for this exact same scenario. So let's do the sixth term. Okay, so if I wanted the sixth term for this one, that means we would want our n is still 7, and if it's sixth term, that means we'd have a k of 5. So then if we plug all those things in our sixth term, so 5 plus 1 is 6, we'd have 7c5, x to the 7 minus 5 is 2, and y to the 5. So that should be our sixth term. If we go back to the other page, our sixth term is this one, so that was 7c5, x squared, y to the 5th, which is exactly what we got. So it does work. You just got to remember to change your n or your k to be one less than what you want. If you want the sixth term, you have a k of 5. If you want the fourth term, your k is 3, and so on. Okay, so let's try another one. This one looks, actually before we do this one, let's go back to this one. Okay, so this one works the same, and we could expand it out the same, and we won't necessarily do all of it, but we'll see that we get the same idea. So we change letters, that doesn't matter. So let's just think of this if it was x plus y, but we'll change it to a and b. So we'd have 5, so we want 5c0 will be our starting point. We'd have a to the 5 and b to the 0. Then our next term would be 5c1, a to the 4th, b to the 1, and so on. The only thing that's different is we get this negative in here. So what you want to do is you want to treat the negative as part of the b. So we'd actually have negative b to the 0 and negative b to the 1. And then our next one would be 5c2, a to the 4th, negative b to the 2. And let's do one more, 5c3, a to the, wouldn't be a to the 4th, that last one. Let me fix that, it'd be a to the 3. So our next one would be 2, and then negative b to the 3, and so on. So now, when you get these, you just got to simplify it a little bit more. So 5c0 is 1. So we have 1 times a to the 5, and anything to the 0 is also 1, so that'll just simplify to a to the 5. The next one we got 5, a to the 4th, and negative b to the 1. So a negative b to the 1 would be the same thing as just minus b to the 1. So the minus 1 times the 5 would give us negative 5, a to the 4, and then b. The next one we have 5c2, which is 10, a cubed, and then negative b would be b squared. The negatives would cancel, so that one will be plus 10 a cubed b squared. The next one we'd have 10 again, a squared, but now it's negative b cubed. So that one will be minus 10 a squared b cubed. So you can see the pattern works where you just sort of, when you have a minus in there, it just switches back and forth between positive or negative. So we don't need to do the rest. We can kind of see the pattern. So if we were to continue, it would be 5, a to the 1, b to the 4th, and then our last one would be negative b to the 5 would be our last term. Okay, let's do one more. So in this case, we don't have a negative, but we have an x squared, and we got a regular number. So still do it the same way. So we got a 5 again. So we want 5c0 as our first number. And then now we're going to take x squared as our first term to the 5, and then we're going to have 2 to the 0. And then our next one would be 5c1, x squared to the 4th, and 2 to the 1. Then we'd have 5c2, x squared to the 3, 2 to the 2, and we'll stop there. We can continue the pattern on from there. So let's just simplify these a little bit. So 5c0 is 1, x squared to the 5 would be x to the 10, 2 to the 0 is also 1. So that first term will just be x to the 10, which we can see if we had x squared times itself 5 times, that would give you x to the 10. So that's correct. Let's do the next term. So we have 5c1, which is 5, x to the 8 times 2. So we'd have to go 5 times 2 would be 10, x to the 8. The next term, 5c2 is 10. Now we got x to the 6, and 2 squared is 4. So we actually get 40 x to the 6. So just remember to times those numbers to actually simplify. And we could continue. The next one would be x. You can see the pattern of the exponents. We got x to the 10, x to the 8, x to the 6. So our next one would be x to the 4th, and we'd have an x squared, and then just our whole number. So that would be our next 3 terms missing. We don't know the front number. We'd actually have to FOIL that out a little bit and figure it out. But it just follows that same pattern. Okay, so let's try our formula again. So let me go back and I'll copy down the formula just so we have it handy. So it's tk plus 1 equals nck times x to the n minus k times y to the k. So that was our formula, so let's try it. So we want the third term. So what you want to do is look at it. We got our exponent of 6. That means we have an n of 6. And if we want the third term, that means we want a k of 2. So if we plug all that in, we'd have t, 2 plus 1 is 3. So we want the third term, so that's good. So we do 6c2, which you could kind of figure out because our first term with the 6 would be 6c0, and we'd have 6c1. So the third would be 6c2, so that's good. Now we have x, which in this case, our x is just that first term, so we'd have 5a squared, and we're going to do that to the power of 6 minus 2, which is 4, and then our second one is just the 2, and that'll be to the power of 2. So all we have to do now is actually just simplify all this out. So 6c2 is 15, so we have 15. And then 5 to the 4, 5 to the power of 4 is 625, so that'll be 625 a to the 8th. And now 2 squared is 4, so we actually just have to multiply all these whole numbers together. So 625 times 15 times 4 gives us 37,500. So it's a really big number, but that's what it'd actually be. So, and you could FOIL it all out, and it would work exactly right. Okay, so let's try one more. So it's another similar question, but it's asking what would be the term that have a to the 5th. So this one's a little bit harder. They don't tell you the second or third or fifth term. So let's actually do the first couple, and then maybe we'll figure out the pattern. So in this case, we've got a 7. So we'd have 7c0. Then we'd have our first term, which is a cubed to the 7. And then our second term, minus 2a to the negative 1 to the 0. And then our next one would be 7c1. We do a cubed to the 6, negative 2a to the negative 1 to the 1, and let's do one more, 7c2, a cubed to the 5, and negative 2a to the negative 1 to the 2. So let's just simplify these and see if we can figure out what the pattern is here. So 7c0 is 1, it'd be a to the 21, and that would just also be 1. So we just have a to the 21 for our first term. Our second term, we'd have 7, a to the 18, and then we'd have negative 2, a to the negative 1. So if we combine those, that would give us negative 14, a to the 17. And let's do one more. 7c2 is 21. Then we'd have a to the 15, and then minus 2 squared is 4, a to the negative 2. So if we put those together, that would give us plus 84 a to the 13, and so on. So that's good enough. We can kind of see that our first term now is a 21. Our second term is 17, and just in terms of the a, our next one is 13. So we know if we continue the pattern, our next term would be a minus something. We don't know the front number, but we know it'd be a to the, we'd take away 4, we'd have 9. Then our next one would be plus something a to the 5, and that's the one we're looking for. So we can see in our list we want the 1, 2, 3, 4, 5th term. So now we should be able to use our formula. So we want 5th term, so that means our k is 4, and our n is 7. So let's plug that in the formula. So we'd have 7c4, and then we'd have our first term, a cubed to the 3, and minus 2a to the negative 1 to the 4. So we just need to simplify that out. So 7c4 is 35. That'll be a to the 9, and then negative 2 to the 4 would give us 2 to the power of 4 is 2 times 2 is 4, times 8 would be 16, so we'd have 16 a to the negative 4. So if we go 35 times 16, we get 560 a to the 5. And that's what it's asking, which term has the a to the 5. So it would be 560. So quite often they might give you a question like this as a numerical, and they just ask, what is that front number? We know it's got to be a to the 5. The trick is, what would that front number be? And that's it.